My name is Kaiwen, and today I'll be conducting the mid-year revision for eMath. So this session is specifically for Sec 3s and Sec 4s. Later I'll explain to you why I've combined the session together. But first off, let me give a short introduction of myself first. So yeah, my name is Kaiwen. So I'm the AMath and eMath tutor for Overmark, and I've been tutoring for about 5 years now. And in Overmark, I primarily teach group tuitions and also the crash courses. So currently right now, I do have group tuition classes. So later there'll be more information about that if you're interested. And also later there'll be more information about the upcoming eMath crash courses for the O-level syllabus. Okay, so this is just some brief background, a picture of me. So you can see this was taken fairly recently, so I still look the same. So I'm currently in NTU right now, and I'm in my 3rd year. Fun fact, I just finished my exams today, like at 11 a.m. So I have officially completed my 3rd year, and now I have a 3-month holiday before my 4th year in uni, and I'm actually studying mathematics in NTU. So what I study specifically is pure mathematics, and my area of interest is like topology, differential geom, and everything. Yeah, funny today my paper was on differential geom. So yeah, so I'm the math tutor, and I'm here to help you guys with your math and show to everyone that math is actually not that difficult, and yeah, give everyone let everyone understand that math is actually not that difficult. Okay, today's agenda. So what I will be doing is going to be slightly different from what the other subjects are actually doing. Other subjects, they actually split it up into Sec 3s and Sec 4s. But for me, because I'm running a little bit behind time, I have quite a packed schedule. So I have no choice. I've combined the Sec 3s and Sec 4s together. But when I was thinking about it, I realized that actually the Sec 4s, some of you may have actually forgotten your Sec 3 concepts. So that's why this can be a very good opportunity when I'm going through the Sec 3 topics. And then for the Sec 3s, if you're in this call, maybe the Sec 4 topics may not be so applicable, or those that you haven't learned yet, but it's just a short little teaser of what is to come very soon. I'll be sharing some of the harder topics to look out for as well for the syllabus, including Sec 3s and Sec 4s. And then I will do a full syllabus revision in the 1 hour and 15 minutes I have. So I'll cover every single topic, touch some important things, and of course, breeze past some of the easier stuff. Okay. If anyone here has any questions for me, at the very back after the QA, after the end, there will be a short little like 5 minutes, 10 minutes Q&A session. So if you have any questions, please leave your questions to the very, very end. Okay. Also, right, try to stay all the way because there will actually be a little quiz, a little Kahoot quiz. I believe all the other subjects have done it as well. So there will be a giveaway for 1 set of the curated notes that I have written. So yeah, if possible, stay back. It will be 10 true-false questions on primarily algebra. So everyone will be able to do even Sec 3s and Sec 4s. Okay. Without further ado, let me first show you this is the full syllabus, and this is every single topic that we'll be covering. Of course, not for today. Today, the only topic that I will take out is vectors, because most Sec 4s have only just started learning vectors, but I will try my best to cover every other thing I try. No promises. And some of the more difficult topics to take note of. So for the Sec 3s, I believe most of you will have already finished Trigo and coordinate geom. You're about to touch into radians and sectors, then congruency, similarity, then properties of circles. These are the 4 difficult topics in the syllabus that a lot actually do have some struggles with. So if possible, you do need the practice in these topics, and also, of course, algebra. A lot of students are not good at your algebra, even though algebra is not a difficult topic. So please practice. There are a lot of resources available. Later at the very end, I'll be sharing with you some resources that I have provided for the channel, and also if you need, you can look for me. For the Sec 4s, this year, when you're studying for your O's, it's very fortunate you only have 3 to 4 topics left, which is set language and notation, matrices, vectors, and I believe the cumulative frequency curve chapter. Now, of course, I think for my Sec 4s, you should already know that vectors is a very difficult topic. It's the worst of the worst. So yeah, for today, I will not be covering that because I don't think it's in majorities of your mid-years. So if we need a lecture on vectors, maybe we can talk about it in the future. Okay, so let's get started. So how will I be conducting this revision section? I'll be using these handwritten notes that I have written last year for my students. So it will look something like this. So it's on a black piece of paper because it looks aesthetically pleasing to me. So I hope everyone is fine with that. I'll be zooming in, so don't worry. This document, right, I will upload into the channel later after the AMAth session. So don't need to worry if you cannot copy fast enough. This also does not contain everything in the syllabus. It contains the little nitty-gritty things that you need to remember for the exams. Okay. So without further ado, if no one has any questions, let me get a sip of water and let's officially begin with the first chapter. Okay. So chapter 1. No, this will not be found in the curated notes. This is just my own handwritten notes. This is for free. I usually give this out to students when they are about to sit for their O's. So don't need to worry about it. Okay, I'll upload later into the Telegram chat after the AMAth session. So if you want it, you can take it there. Okay. So I'm going to start, and I don't have much time because I have a lot of topics. So I will not rush. Okay, so, so let's go. First chapter, numbers and the four operations. So in this chapter, there are a few important concepts that we need to remember. First one will be LCM and HCF. So when we are dealing with LCMs, we are always looking for prime numbers, and we are always dealing with the highest possible power. For HCF, it's the other way around. We are always choosing the lowest possible powers whenever we are dealing with a HCF or LCM question. There are many variants on HCF and LCM questions. If you need, there are many sample questions out there, and I believe schools will have shown you the different types of questions specifically just for these two concepts here. For perfect squares and cubes, you just need to remember that the powers are of a very special number. Perfect squares means that the powers of multiples of 2. So I repeat, multiples of 2. And then for cubes, for cubes, right, there are powers of 3, multiples of 3. So for example, power 6 is cube as well. Power 4 is actually a perfect square. So these are examples that you need to know. And why this is important, because there are questions out there where they will ask you, oh, I have a number multiplied by an unknown a variable. What make it become a perfect square? Then you need to know, okay, we're just going to look for the powers. Like for example, this example here, let me use white pen, so maybe yellow. Yeah, these 3 here. So I want to make it to become a perfect square. So I need to multiply by 2 to make sure that I can get it to a perfect square. So this is the technique that you need to know how to do. Next is number lines. So drawing of number lines are important. You need to know the number lines usually look like this. Now there are 2 formats of how number lines are drawn. Those that have the inequality with the x in the middle, and for those with the x's going towards infinity. So there are differences of how you draw. For those going towards infinity, you point towards infinity, of course. And then for those that are not, then you just point towards each other. Now, some schools, they do teach you to draw it in different ways. Follow what your school does. This is how I teach my students. One thing also, this is something that I realize that many students do. They like to partition every single point. If your school says that you need to, go ahead. But personally, for me, I don't think that is very necessary. What you should do is just write the endpoints, and that should be safe enough. So for example, if a question asks you to go from -20 to 50, are you going to write all the way? No, you don't have the time. So if possible, just write only the start and the end. For the inequality, the solid circle and the hollow circle, I will share later during the inequalities chapter. Okay. Now, approximation and estimation. So this is something that everyone already knows. So when you are rounding down is when your number is between 1 to 4. Rounding up is when your numbers are from 5 to 9. Now let's talk about this. This is very important. This is actually written on your exam cover page, if you didn't know. So there are specific roundings that we need to remember for the O's. For money values, we are always writing it in 2 decimal places. For angles, we are always in degrees, we're always writing in 1 decimal place. For angles in radians, it's in 3SF, and everything else in the universe is in 3SF. This is a very important thing about the 3SF, because many students will forget, and if you don't, you will actually lose marks during rounding, and that is a very sad mark to actually lose for exams. Now, of course, you do need to follow what the question say. Sometimes when the question says that leave your answer in 3 decimal places, of course, please follow. Standard form. So standard form is a times 10 to the power of n, where the value of a is in between 1 inclusive and 10 exclusive. This is very important. Many students will make careless mistakes here when you're writing your standard form. Make sure that the number is always between that range. Now, if you see there's this ENG calculator thing here, so I think a lot of people don't know this. On your calculator, there's an ENG button. So I'm going to show you my calculator now. So this is my calculator, the Casio FX 96SG Plus. Now, no matter what version of your calculator that you are using, okay, you can press this ENG button. I hope that my video, let me just check my video, it is clear. Okay, let me unblur my background. Sorry, my room very messy. That's why I blurred my background. Okay. Ignore the clutter at the back. So there's this ENG button down here. Okay. So if, for example, if you're typing a number like 1 million, like this, okay, and you press the ENG button, oops, yeah, ta-da, standard form. I hope you can see. Okay, so you press some more, you will actually go even into standard forms. Yeah, but do take note that this one is not accurate to what the exam wants, like 1:8:10, because this is more for engineering students, but students can use this to cheat to actually get your answer out for standard form. Okay, so secret if in case you didn't know that. Okay. Oops, sorry, not pause my video. Blur background. Okay, next. Everyone's beans of existence. Indices law. So indices law is something that a lot of students don't like, even though it's not very difficult, just practice. So there are some laws that we need to remember whenever the bases are the same. So for example, A and A with different powers, we are always adding the powers. Now this is different from this case. This case is when you have something holding power n. Then it's a multiplication. A simple way that I do to help myself memorize is to use this example here. Okay, I will take A to be 2 and take M to be 2 and N to be 3. And then I compute, I see it's 32, it's actually 2 power 5. So this will remind me that, oh, okay, it's not 6, because if it's 6, it'll be 64. So this should be power 5. And I remember that, same base, different powers, multiplied together means you are adding the powers together. So this is very important. Another one that is important as well, whenever you are taking a square root, okay, you are looking for the power of half. And then also if it's an nth root, then it's 1 over n. If you're taking a reciprocal, then this is power minus power. So for example, if you're moving things from the denominator to the numerator, you take a negative power. For prefixes, this is a list of prefixes that you need to remember. Now, of course, in this set, I didn't write, so I'm going to show you using my curated notes. So, this list. So this whole list, starting from pico all the way to tera, is actually very important. It's good to know every single one. If the schools are very nice, they will give it to you, but most of the time they don't. So you need to remember, oh, pico is 10 power minus 12, tera is 10 power 12. Everything in between is just what you need to remember. A simple memorization technique is to remember that all the powers are always in multiples of 3. So that's how I always remember. Then just go pico, nano, micro, milli, centi, deci, kilo, mega, giga, tera. And then you just repeat this every day, it will come to you naturally. Okay, and that's the first chapter. Pretty fast. Okay, let's move on. Ratios and proportion. So for this chapter, there are important things. The important things for this chapter is actually the question type. I wouldn't say the concepts are very difficult. The questions are important. So let's start off first with the graphs. So ratio and proportion questions, a lot of students will forget to study the graph. And that is very sad. So please remember to study how your direct proportion graphs and inverse proportion graphs look like. I've actually sketched some of them here. So if you're a direct proportion with y against k, it's a straight line. Y against x squared is a quadratic curve, so it's only the positive part of the quadratic curve. Inverse are always your reciprocal graphs. So if you remember your functions and graph chapter, your 1 over x curve and 1 over x square curve are always of this form. That's how I memorize my inverse curves. Inverse curves are always like this. Please, it is not this. This is wrong. It's not a straight line. Okay. So the key value down here that I've written is actually a constant that is meant to be found. So in exams, you do need to go and search out for the value of k using the unknowns given to you or using the variables given to you in the exams. Now, the two question types that I want to focus on for ratio and proportion is primarily for worker questions and the map scale questions. Sorry. Okay. So for worker questions, right, you need to remember this. When the workers go down, the number of workers go down, the number of days will increase. I'll give you a very simple example that is relatable to everyone. Let's say, for example, if you're doing a group project, your school asks you to do a group project, and you're given 6 people in your group. And out of these 6 people, 5 of them decide not to do anything. And then you GGWP. So you need to tank all of the work yourself. Will the amount of effort increase or decrease? Obviously increase. The amount of work that you need to do to replace these people's work will increase. So that's why it's always an inverse proportion. Same thing for the number of workers. Let's say, for example, if you're doing a group project of 5 and your whole group not doing anything, right? Then your teachers pity you, give you additional people. And these people will do work. Will your work drop? Of course. The amount of work will definitely drop. Okay? This is how I memorize this scenario. Map scales. Map scales are those that always have the ratio 1:n. Now, some important things that many students will forget. 1:n is always in centimeters. And there are always no units. So please don't ever write 1 cm is to 30,000 cm. That's wrong. It's always 1:n. For those that learn geog, that takes geog, you should know this as well. So this is a common concept there. And how do you convert between area scale or linear scale to area scale is actually just squaring both sides of your equation. So 1 cm, when you square it, becomes 1 cm squared. Same thing for the left. If it's in km, then km squared. Now, a very fortunate thing about this particular concept of map scales here is that all of the question types are very fixed, and there's only 5 in the whole syllabus, to be very honest. If you know all these 5, you can definitely solve. Some of you may see some page numbers written here. Now, what are these for? These are actually linked to the curated notes. So on page 44 and page 45 of the curated notes are actually all the 5 question types for map scales. Okay. And we're done with this topic. So, okay, I think after every topic, I will look at the chat. If I see any interesting question, then I will answer. Oh, sorry, a good question, then I will answer. Okay. What does the A stand for in the header of these notes? I got A. Okay, never mind. That's not a question. I saw something. Should we always leave our answer to cert form or TSF if they don't say anything? TSF. Yeah. Difference between y over x and y and x square. Oh, it's the same thing. So I assume you're talking about the inverse graphs. They are the same thing. Later, when I touch the functions and graph chapter, you will see that the curves are exactly the same. Okay. So I will stop questions here. Let me just check. Will they test on how to draw exponential graphs in EMATH? Yes, they do. Later, I'll touch on that in the functions and graph chapter. Okay, I'll move on. Percentage. Okay, so as you can see, I'm a very happy person. I love math. So I will try to make everything very, very fun. Okay, so I hope everyone's enjoying yourselves and learning something from me. Okay, percentages. So percentages is a very simple topic. I hope everyone can tackle this chapter well. But I know there's a small, tiny group of students that cannot do this chapter. And I know why. It's because you don't know how to identify what is your 100% and what is not your 100%. Actually, there are ways to check one. You just need to read the question very carefully. And I teach you how. First thing, okay, when you're dealing with discounts, please remember that the amount of money needs to decrease. I have students where the question asks for discount, the money went up, which is a bit funny. So please be very careful. Now for exam questions, right, there are two types, and I'm going to use a bit of English here. So I'm not an English tutor, but the simple, what do you call these kind of words? Conjunctions, yeah, they are important. The word by and the word to. When you're decreasing by something, it means they are taking 100 minus 20. Okay, and when you're decreasing to 20%, then it's 20%. So you must be very careful with the word by and the word to. Please don't just only zoom in on the number and don't read the word beside. So that is a very dangerous thing to do. If you're increasing by something, then you're increasing and you add that particular value in. So you'll be 115% for the 15% one. This is a very important formula here. So percentage change, percentage increase, or percentage decrease. This is the formula. Final minus initial over initial times 100%. What does this mean? It means you're going to take the final value that you have calculated minus the original over the original times 100%. What is this reduction thing at the bottom? This is a very common mistake that many students make. So let's talk about it. Whenever questions ask you about reductions, right, please remember that when the question says, please find me the percentage reduction of this thing, when you calculate, you will get a negative value. But when you write onto your answer line, it must be positive. So please be very careful. The reason is because the word reduction there already implies the negative sign. So if the question says reduction, you calculate out your answer is negative, please present a positive answer. Because with the word reduction in the question, it will mean the negative answer. I hope I never confuse any of you. Okay. Rate and speed. Okay, let's see some questions. How do we deal with profit margin? Wrong chapter. Can you kindly go through the terms or interest related? Wrong chapter. Percentage change and percentage. Okay, what if they say percentage change? Okay, some of you are actually direct messaging me. Actually, if possible, right, you send to everyone. So for those that actually know the answer, you can actually help me answer. So I don't need to answer everything. Okay, yeah. What if final minus initial 100%? When is it used? When the question asks you for percentage change. So it's very obvious one. Okay. Can I use physics concepts such as acceleration formula for the graph chapter? No. Answer is no. So your A is equals to V squared minus U squared over T, right? That one? No, cannot. Okay. Stick to math. Okay, that's all. Rate and speed. So this chapter, not difficult. The only thing difficult is the interpretation of the graph, which I'll come to in a while. So average speed is always talking about the total distance over the total time. This is important. So if you're given a big graph, when you want to find what is the total distance or what's the average speed of the whole journey, please remember to tabulate the total distance over the total time spent. When you're doing conversions, now a lot of students, they go and memorize the conversion. Now I tell students, please tell my own students, please don't ever do that. Do it step by step. Let me show you a demonstration here. If the question asks you to convert between km per hour to meters per second, what does it mean by km per hour? 1 km per hour means 1 km in 1 hour. So what does 30 km per hour mean? It just means 30 km in 1 hour. Write it this way, and then you convert your km into meters, convert your hours into seconds, and then you get your answer. This is so much safer than using the memorization technique. And most of the times, for students that use the memorization technique, you actually tabulate wrongly. So be very careful. Let's go into the most scary concept here, which is the interpretation of graphs. So interpretation of graphs means what? You will need to be able to convert between a distance time graph to a speed time graph, and from a speed time graph to a distance time graph. So this chart down here, okay, my AMF students will actually see it later in the kinematics topic, but this chart is very important. Let me explain how to read. I will write distance, speed, then acceleration in this in order like this, and then I'll draw arrows. When you are given a distance time graph looking for the speed time graph, we are going to tabulate the gradient. If you're given the speed time graph looking for the acceleration, we tabulate the gradient. If we're given an acceleration time graph, looking for the speed, we tabulate the area under the curve. Speed time graph, looking for distance, we tabulate the area under the graph. Now, of course, you don't need to write it so nice lah. Most students will just do D as A. Oops, sorry. A, then just remember that this is G, and whatsoever. Apologies for my horrendous handwriting. Now, this graph will actually tell you what you need. So if the question gives you a speed time graph, just remember, okay, question asks me distance. I straight away look at my diagram. I know I'm going to find what is the area under the curve. Okay. Now let's talk about some common mistakes. First one, if you're given a distance time graph with a horizontal line, please remember this means that the object is stationary. Okay, because the velocity or the speed is 0, the acceleration is also 0. Therefore, the object is not traveling. So please don't be funny. If they give you a distance time graph and the distance is actually a horizontal line, the guy is not supposed to be moving, assuming that he's inside a shop buying something. Okay, he reached the shop, then it's a straight line for a short while, then go back down. Please remember that the stationary part up there, the guy is not cycling his bicycle in the shop. It doesn't work that way. Okay, remember it's stationary. Now, two things. Constant speed and constant distance. Now, constant speed means that you are not accelerating. This one don't need physics to know. Okay, if you're moving at the same speed, are you speeding up? Abu then no. Okay. If you're moving at a constant distance, means that if from here, I'm sitting right here, am I moving? No. Okay, I'm not changing my position at all. So I'm not moving. So my velocity will be 0, or speed will be 0, and my acceleration will be 0. Okay, now comes to the scary part. How do we convert between speed time graph and distance time graph? Now, unfortunately, I don't have the time to physically one by one go through, but I can show you this that will help. So I'll go into my curated notes first. Here. So the way I've done it is that there are many different types of distance time graphs out there. You just need to remember what the following conversions are. So for example, if the distance time graph is a horizontal line like this, this means that the object is stationary. If the distance is going up, it means that the object is in uniform speed. It's the same thing. If you're in a curve, it means that you are increasing. And for this, decreasing. Now, the reasons why, later at the problems in real world context chapter, I will explain why these curves means increasing gradient or decreasing gradient. But this is actually how you remember and how you plot out properly. So here also in my notes, I've also used some of the worked examples. I've actually explained out fully why the graph is supposed to be drawn a certain way. If you have actually practiced enough this kind of interpretation of graph questions, right, you will know that actually you can memorize every single graph conversion. If you're given a horizontal distance time graph, what is the corresponding speed? If you're given a speed, what is the corresponding distance? Most of the time, it's always identical. So fun fact, you can actually memorize that if you are not interested in the understanding process. So go and work it out and you'll be able to get it. And I'll move on to the next chapter. Okay, I'll check the comments. But I got use physics formula to find acceleration and they mark correct. Oh, then your school very fortunate to you. Your school very nice to you. Sure, if you can use, it's fine. I mean, the reason why, right, is if you never realize okay, assuming that my physics that I took 7 years ago still there, the acceleration formula is A is equals to V minus U over T, right? I assume. So assuming that you're tabulating the acceleration, yeah, this thing is just gradient if you didn't realize. Okay, so for example, right, if you're starting from here, this is your initial velocity, this is your final velocity, this is your T. You just tabulated the gradient. So it's the same thing. Yeah. Okay, so if you want to use, if you write this in your exams, it's the same thing because you have just tabulated the same thing. Okay. Is knowing the main concept for that chapter enough? How much can they alter the questions? I assuming you're talking about area, this kind of rate and speed chapter. To be very honest, not a lot of variation, to be very honest. But you never know. Anything can come out. So if possible, try to practice as many possible types as possible. Okay. I'll move on. Okay, because I don't have much time. Sorry, who's that? If possible, please mute. Thank you. Okay, great. Okay. So I don't have much time, so I'm going to carry on first. Okay, let's go. So algebraic expressions and formulae. Okay, I have 45 minutes to finish another few more chapters. So algebra. Now, why is algebra important and why many students cannot do is because you never practice enough, guaranteed. So algebra has a few concepts. First one, changing the subject of an equation. The manipulation of equations, most students can do. The thing that most people will forget is when you're square rooting something, you must remember to take plus minus, because this is something that a lot of people will forget. So please be very careful. For this forming quadratic equations question, right? This is the one in paper 2 where they always ask you like, oh, part A, this person traveled from town A to town B in 30 minutes. Given a distance of x, find the speed. Then this person slow down his speed, find the new speed. Part C, using the two above parts, form a quadratic equation. Part D, solve the quadratic equation. Part E, find the time taken, something like that. Okay, when you're doing such questions, if let's say your part A and part B, you can do very good. If you cannot get the quadratic, it's not the end of the world. Okay, because the quadratic part is usually 3 marks. The remaining parts still can solve. So please, if you give up the 3 marks, it's fine. The remaining 7 out of 10 marks, please go and do. Okay. Now, this kind of topics, there is a specific question type, which is the profit and total one. Be careful. Whenever questions are asking you for what is the profit, it's always, for example, whatever you have earned minus your expenditure. If you're looking for the total, it's your product multiplied by the price. Okay. Algebraic identities. So these 3 algebraic identities are very important. Please do not confuse yourself in exams. A plus b square is equals to a square plus 2ab plus b square. A minus b square is equals to a square minus 2ab plus b square. A square minus b square is equals to a plus b, a minus b. These are important. Please don't forget. Factorization. Whenever you are factorizing things out, please remember that your objective is to take out a common term. So for example, if it's ax plus ab, you can pull out the a because they're common between both numbers. Now these 4 terms I'm not going to go through, so just leave it here. Now for quadratic equations, whenever you are simplifying quadratic equations or quadratic expressions, there are 2 ways of doing it. It's using the box or the quadratic box method. Remember, your calculator gives you mode 3, okay, it can help you tabulate. And the last one is completing the square. Completing the square is a very important concept. Okay, if you have problems with completing the square, please look for me personally. I can help you with this. Now, algebraic fractions. Now, this is something that usually when I mark my students' work, I vomit blood because this is something that students cannot do or they anyhow do. So please remember that when you're dealing with when you're dealing with algebraic fractions, you cannot anyhow cancel. When you want to cancel, you need to make sure that every single term in your algebraic fraction contains that term, then you can cancel. So please be very careful. And whenever you have 2 sets of fractions, please remember that you need to make a common denominator. Then you can form them into a single fraction and then you can solve. Okay. Number patterns. So this formula here, Tn is equals to a plus n minus 1 times d. Not every school will learn, but I usually teach my students this. This is important. This number pattern here will give you the pattern for a common difference pattern. So for example here, 2, 5, 8, and 11. So if you're jumping in between numbers of a common number, like for example, 2 to 5 is plus 3, 5 to 8 is plus 3, 8 to 11 is plus 3, you can use this formula. A plus n minus 1 times d. Okay, if you're interested, this is called an arithmetic progression, AP, or usually taught in A levels, but many schools actually do teach their students this as well. Now, unfortunately, for number patterns, right, for all the other patterns, like those with like differences, those have no fixed formula. You do need to go and brute force the answer out in exams. Okay. Okay, and I'm done. Functions and graph. Read the comments and I'll move on. Can we get these notes? Yes, I will send later. Thank you. Thank you for answer. Thank you. Okay. Okay, so like I said, if anyone has any questions here, we are a community here, okay, because I'm trying to go through as many things as I can in the next 35 plus minutes. So if you can answer the question for me, you help me answer, okay? But please answer correctly, I'll be checking, okay, please don't anyhow give wrong answers, please. Thank you. So functions and graph. This chapter, not difficult, okay? We need to remember the 6 total graphs that is possible to be sketched: line, quadratic, cubic, reciprocal odd, reciprocal even, and exponential. So just now when someone asked me what's the difference between k over x and k over x squared, if you look at your 2 graphs, the positive side is always like that. Okay. Now, a funny name that I use to memorize all of these, right? I let you guys know, it's stupid, but helps to memorize. Okay, line is called line, nothing different. A quadratic equation is a cup, C-U-P, cup. A cubic is like a slide. Okay, so it's like a slide. Reciprocal odd looks like a basketball. So I just remember whenever I see reciprocal odd, it looks like basketball. And then all the basketball players are going to kill me after I say this. Okay, then reciprocal even looks like a volcano. Okay, because like that. Okay, don't ask me why, it's just how I memorize. And exponential looks like a banana. Okay, so that's how I remember all my 6 graphs. Okay. Now, whenever you're sketching a quadratic curve, please remember that you need to look out for 4 things: your x-intercepts, your y-intercepts, your happy face, sad face, and your turning point. Now, depends on what kind of equation you're given. If you're given the x-intercept form, then you can read off the x-intercepts. Turning point, you tabulate using midpoint. And if you're given the turning point equation, then you have the turning point already. Okay. Please remember that if you're checking for happy face and sad face, if the value of A is less than 0, it's a sad face curve. Greater than 0 is a happy face curve. And for that, why is it like that kind of face? It's because A equals to 0 means they are looking for a straight line. So the curves look like that. Okay. 2 things at the bottom. Line of symmetry. Remember that when you are dealing with the line of symmetry, we must remember that line of symmetry is an equation. Okay, it's not just a number. A lot of people, when a question asks for line of symmetry, they just give me 2 and they expect to get it correct. No, x equals to 2. And then for turning point, please remember that you can read off the turning point form h comma k. The turning point form is ax minus h holding squared plus k. The turning points are h and k respectively. You need to be very careful. It's x minus h. So for this example right here, since it's x plus 3, this means that there is a minus sign. So it's x minus of minus 3. Therefore, h is negative 3. Okay, so be very careful. Next, equations inequalities. So this chapter here is very similar to the sister chapter at the side. So that one, all those concepts that are related, I will ignore. But the ones that I want to tackle a little bit on will be simultaneous equations. For simultaneous equations, you must remember that we are dealing with the substitution method, elimination method, and the graphical method. Graphical method may be not so popular, but remember the graphical method is actually your point of intersection between 2 lines. So if the question is asking you for, what is the solution of these 2 equations? It's always the point of intersection. Okay. When you're solving for quadratic equations, please remember that you can use the box or the quadratic formula. The quadratic formula is not given to you in the formula sheet, so please go and memorize negative b plus minus square root b squared minus 4ac over 2a. This box one at the side here that I've written, now this one is a memorization technique or special technique. I will not teach here because I don't have time. So I'll just leave it here. If you understand what this is, good for you. If you don't, you can PM me. And the last one will be the linear inequalities part. So just now in the start, when I mentioned about linear inequalities, whenever you're given 3 sets of inequalities, which is most of the time how they test, remember that you're splitting up the first 2 and then the back 2. So use this visual representation here to memorize. Square less than circle less than triangle. The square is less than the circle and the circle is less than the triangle. Then you solve them respectively, solve for the final answer. Okay. Now this word that I've arrowed here in the middle, this is important. Some people write the word or, and that is wrong. You only write or when you're solving for quadratic equations. For inequalities is the word and, because it is inclusive of both sides of the solution. Set language and notation. So this is a Sec 4 topic. So for my Sec 3s, this part not very important. So I mean important, but not now. So can just listen. Okay, treat my voice as background music for a while. So set language and notation. When we are dealing with the union or something, just remember that we are combining something together. So we are just going to, for example, if it's A union B, it's the combination of A and B. Very simple way to memorize. Union is like a marriage. So you are marrying two people together, you're combining these two people's things together. So therefore, A union B is both of the things together. Intersection means that you're looking for things that are common. So the middle chunk there will be the common things. Okay. Now you need to remember that also, if there's a value of n written beside the A set, that is referring to the number of a set. And then the notation with the null symbol, that is a set notation. It is wrong to actually write them into the same equation. So if you want to write it, you must write A, which is a set language, equals to the set, or the number of elements in the set is equals to 0. So please be careful. For Venn diagrams, remember that when you are drawing a Venn diagram, you must remember to label your universe. Your box must draw. Okay, use ruler, of course, use pencil, and remember to label your sets so that you don't make mistakes. Last one for shading. So remember that if you want to shade something, excuse me, the technique that I teach people is that you shade them separately. So for example, if it's A union B complement, we shade the A first, we shade the B complement, then we combine them together. Okay, unless your shading is very strong, then one shot can just shade everything. Okay. Next one will be matrices. So this topic is also Sec 4 topic, not very difficult topic. I think it's a pretty easy topic. So matrices, first thing you need to remember is about the dimensions of a matrix. So dimensions is always written in row times column. Just remember length times breadth. So the number of rows multiplied by the number of columns. Now, this is not a number. So dimension is like a size. Okay. For example, if you're telling someone what is the dimension of your box, you don't tell them the final answer. You tell them, oh, 20 cm by 20 cm by 20 cm. Okay, so it's just the size, how big they are. When we are dealing with multiplication, okay, the addition, scalar addition, that one I think are very easy, so I won't touch. But for the multiplication, it's important. So remember, whenever you're dealing with matrix multiplication, the middle two letters must be the same. So a simple way that I ask students to remember, just imagine you're taking the MRT. If you're traveling from maybe from Clementi to Jurong East, and then from Jurong East to Boon Lay, okay, your middle two is like your middle junction. It must be exactly the same, or else it is not possible to multiply. So for example, 2 by 3 multiplied by 3 by 1. Okay. It cannot be 2 by 3 multiplied by 2 by 3. Cannot. You will get it wrong. This example of the rings drawn here, so the red, green, and yellow, this is how we actually do the matrix multiplication. So just have a look at it. Okay, it will be the red, which is the row, times the column of the yellow. Then you just need to add all of the multiplications together to get the final answer. Okay, and we're done. Very good. Last algebra chapter, then I'll check the chat because I'm running out of time. Half an hour for the remaining chapters, I think it's good. Sorry, please mute whoever is in that. Thank you. Thanks. Okay. So the last one will be the problems in real-world context questions. So for my Sec 4s, if you haven't been practicing enough paper 2 questions, you won't know, or everyone should know, that at the back of the paper 2, the very last question is always this chapter, where it's a very long question, and the last part is always like 6 to 7 marks, when you need to answer like a few things. So please remember that this question is important, and how to study them, of course. Now, someone asked me just now to explain to them what are all the different like values, okay, or different monetary terms. Here they are: simple interest, compound interest, hire purchase. So simple interest is PRT over 100, where the value of T is the number of years. Take note of the green highlighted parts. I'll explain later. Compound interest is the formula there. P1 plus R over 100 to the power of N is equals to T, and this is the total. Remember that compound interest calculates the total. Simple interest calculates the interest, so be careful. The green color highlighted ones are different. T is the number of years, N is the number of times. So for example, if the question says that you're calculating a compound interest, but you're doing it 2 times in the same year, for example, 3 years half annum, it means n is equals to 6. So please be very careful. Last one, for the geometrical graphical interpretation kind of questions, remember that if the question is asking you for the rate of something, we are always tabulating the gradient. And the last one down there, remember just now when I said about the red and sweet chapter, why is it some curves are increasing gradient and why is it some curves are decreasing gradient? Actually very easy to understand. Just look at my video right now, if you can see my video. So why is this graph a decreasing gradient? Okay, just look at how I'm positioning my hand. My graph will start like this, right? So my gradient will be very steep first, and then I'll be going more shallow and more shallow. So what do you realize? The gradient is actually getting smaller and smaller. This is why this is a decreasing gradient. For the other one, like that, going up, increasing gradient. Okay, so this is how you tell apart the two. And we're done. Okay, let's look at the chat. Wow. I got so many messages. Okay, wait. Okay. Don't need to see. Okay. Difference between selling price and cost price. Okay, that one can answer. Selling price is the amount that you sell for. Cost price is whatever the supplier and you bought it for. Okay. Annual compound interest is n if r equals n over 4. Yes, for the compound quarterly question, yes, that's true. For set language, when do I have to write the two brackets union or intersection if they ask me to represent the shaded diagram? Sorry, I don't understand your question. If the background is shaded, is it usually a union? No. It depends on the question. Okay, move on. So there is a possibility that I may not be able to finish. If I cannot finish, I will skip the cumulative frequency chapter. So I'll skip this chapter. Okay, because I don't have enough time. I don't want to overrun. Okay, so I have 1, 2, 3, 4, 5, 6, 7, hold dear, 8 chapters in half an hour. Great. Let's try. Okay, angles, triangles, and polygons. So this chapter is not difficult. So first thing is that for this chapter here, you need to remember every single reason that you write. Complementary, supplementary, all of your opposite angles, angles at a point, corresponding alternate interior, all very important. Please memorize. Remember that whenever you are calculating an angle, it needs to come with a reason. Okay. All the properties of a triangle are very important as well. Same for quadrilaterals. So equilateral, isosceles, please remember how to prove. So how do you prove equilateral triangles? Remember, same number of, the sides are equal length, angles are all 60. Isosceles triangles, the two sides equal length, base two angles are equal. For your square, rectangle, parallelogram, rhombus, and trapezium, please remember all the properties as well. Like for example, rhombus is basically a square that is squished. Parallelogram is just a rectangle that is squished downwards. That's how you memorize. Okay. This one, important. Polygons. So polygons is a chapter that a lot of people just sleep on and don't care. No, important. So polygons has an important keyword, which is the word regular. Whenever you see the word regular, it means that all of the sides are equal. All of the angles are equal. This is very important. The questions will not tell you that the sides are equal or what. They will just use the word regular. So this is very important. Also, please remember all the names. There are questions where they don't give you the diagram. And if they don't, you forget the names, then too bad. So please remember and memorize all the way from 3 to 10. If you're interested, there's actually a list from 3 to 999. Okay, but that one is very far away, not in your syllabus. Okay, but if you're interested, there's like many names out there. Okay. This one, very common mistake. So please be careful. Exterior angles and interior angles. Now remember that the exterior angle is 180 of the polygon, not the whole thing. The whole thing is the reflex. So please be very careful. Don't make careless mistakes here. Okay. Construction. Now, this one here hasn't been tested for 2020, 2021. These 2 years don't have construction question. So we never know for my Sec 4 this year whether 2022 got this question. Don't know. Okay, but just remember that an angle bisector cuts an angle in half. Perpendicular bisector cuts a line exactly in half, and you must show all of your workings. So please don't go and erase your working because you want to make the diagram nice. No, doesn't work that way. You must show all your working. Okay, and we're done. Congruency similarity. This one. This chapter a lot of students hate because you cannot write your proofs well. So just be very careful. So, suddenly got converse in the chat. When do you use converse or something? When do you use the original explanation? For the person that is asking about the converse one, converse is not in the syllabus. The word converse is not in the syllabus unless you're talking about your relation properties, which is not in the O-level syllabus, like contrapositive lah, converse lah. These are not in the syllabus. So yeah, I don't think you're in the right place. Okay, just be careful. How do you prove that a polygon is regular? Is it by showing that? Yeah, you show that the interior angles are equal and you show that the sides are equal. Is there a formula for interior angle for regular polygons and non-regular the same? No, it is different. So I think just now I shown. Oh my god, I don't have time. Where are you? Come on out. Yeah, here. Ta-da. Okay, so for convex normal ones, no regular, you cannot divide by n. But for regular, you can divide by n. This is the main difference between the two. Okay. Yeah, if you want, you can screenshot. Leaving in 3, 2, 1. Okay, go. So for congruency similarity, right? Remember that there are a total of these sets. So congruency questions are always, remember this test, SSS, ASA, SAS, and RHS. Similarity is AAA. Same sides ratio, same sides for two ratios. Same sides ratio for two, and one angle is the same. So usually when we want to prove similarity questions, we always use AAA. We don't use the rest. Usually, congruency can be anything. Now I need to remember a few things about this kind of proving questions. Now, naming conventions. This means that if you're going in a clockwise direction, we all need to go in a clockwise direction. What we do is to always draw out the triangle or use what the question gives you to actually identify how to label. For justifications, please remember that there are a few types of justifications. Number one, same length or same angle. Whenever it's the same, we just say common angle or common side. Now, if the information is given to you by the question, let's say the question says that the angle is 64. Then you can say the word given. This word given very powerful. You cannot anyhow use. It must only be the word given if it's really given to you. If you have tabulated anything or you have calculated anything, you need to write reason. So be careful. Now for area and volume formulas, right? There are two here. So A1 over A2 is equals to L1 over L2 square, and then for the one is the cube. Just remember that this only works for geometrically similar figures. And the questions will usually say that the figures are geometrically similar. There is one exception to this. There's a certain question that won't tell you that they are geometrically similar, and those are polygons and regular polygons. Now just remember that regular polygons are all similar and they're all geometrically similar to each other. This means that if you have a small octagon and a very big octagon, they are geometrically similar. The question don't need to tell you that, you just need to know. Properties of circles. So this chapter here is a lot of students have many troubles with this. The tip for this chapter is to honestly go and practice, because the practice comes from the looking at the question and looking for all the butterflies, looking for all the arrows and whatsoever. If you have problems looking, go and do as many as possible and train your eyes to be able to spot all these kind of special shapes. For the tangent theorems, there are two. Remember that if your tangent is perpendicular to the radius, if your tangent is at your radius, it's at a point and then going to the radius, this is a perpendicular line. If you have two tangents extending towards an external point, actually the lines are equal. this next property, angle at center is equals to 2 times angle at circumference. Take note that the very common arrow shape, so this one here, this is the one that is always tested. Please remember what it looks like. This one is usually for area and sector questions. They will always give you a shape that looks like this. Angles in a semicircle. So remember that if you're in a semicircle, whatever triangle you draw there will be 90. This one, you must remember, this line down here is very important. It must be the diameter of the circle, cannot be anything else. If the question never say you cannot assume, be careful. Angles in the same segment, this is the butterfly. Now, please don't be like my students are, because some people, they remember it as butterfly, butterfly, butterfly. Exam go and write butterfly. Okay, butterfly is not the official reason. Official reason should be angles in the same segment. Important property is that all the 4 sides must touch the circle. So this case down here, this is not angles in the same segment. What is this? In case you didn't know, this is this. Okay, if you want to know why, go and think about it. Okay, the reason is very obvious. Okay, for this particular one, if let's say there's 1 point in the middle of the circle, this is angle at center equals to 2 times angle at circumference. Last one, which is angles in the opposite segment. Okay, this is for a cyclic quadrilateral. So if you're looking for, let's say, a 4-sided figure inside a circle, this 4-sided figure, right, opposite angles will add up to 180. Remember that for the cyclic quad, all the 4 sides must touch the corners of the circle. It cannot be anything else. Trigo. Oh, sorry, Pythagoras theorem. It's just this, Okay, if you're going for exam and you do not know the Pythagoras theorem, I'm sorry for you. Please go and do something about it. Okay, so please remember that it's a squared plus b squared equals to c squared. Remember that Pythagoras theorem only works for right angle triangles. Okay, it doesn't work for any other shape. Trigo. So for Trigo, now Trigo, same thing. It only works, or for the Dorcaso part, only works for right angle triangles. So Dorcaso, sine is equals to opposite over hypotenuse, cosine equals to adjacent over hypotenuse, and tangent is equals to opposite over adjacent. So please remember this. Remember that it only works for right angle triangles, because I still have students trying to apply Dorcaso to non-right angle triangles, and it's very sad. Please be very careful. This is the case where you cannot anyhow use your right angle triangles and your Dorcaso rules. Now, for exterior angles, for obtuse angles, now if you do not take A Math, then you just need to memorize this. But for A Math students, you should know that for the S quadrant and the A quadrant, your S is also positive. That's why sine theta is equals to 180 minus theta sine, of course, all that. And then for the cosine, it is negative. The tangent one is not in the syllabus, but some schools, they do test you. So just remember that tangent is also negative in the obtuse angle quadrant. For my AMF students, you should know ASTC. Your second quadrant is your S. Therefore, sine is positive there. And of course, your A quadrant, everything is positive. Bearings. Bearing questions are important. Remember that all bearing questions are phrased in the exact same way: of something, from something. We will always draw the north line from the from. Okay, so for example, from this case is from A. So we're going to draw the north line from A, connect A to B. The line or the arc that is connecting the 2 lines will be your bearings. You need to remember that for bearings, if you're going for less than 100 degrees of your bearings, there must be a 0 in front of the bearing, or else you'll get it wrong. How schools like to trick students is that your bearings will have a decimal place. So you need to remember 2 things. For decimal place bearings questions, there must be a 0 if it's less than 100. And if there's a rounding off, it must be 1 decimal place. So there are 2 things to take note of. Be careful. Angle of elevation and angle of depression. Now these, just need to remember what they are. Elevation and depression questions are always phrased in the same way as well. Of something, from something. Elevation questions, the of something, from something, right? We always start from the word from, and that is where we draw the eye line. So for the elevation questions, from your eye, you look up. That is the angle that we are interested in. For depression, when we are looking down, that is the angle that we're looking for. Okay. Use whatever method to memorize the difference between elevation and depression. But one thing that I want to say for depression questions, imagine this scenario here. I'm standing on top of a cliff and I'm looking down at a pile of money on the floor. What is the angle of depression of the money from me? Remember that I always start from me because I am important. So I start from me, I look down. That's how I remember. And from down, looking to the money, this is the angle that I'm interested in. And for this angle, remember that your eye line is parallel to your ground. Therefore, that is your theta value as well. Two more concepts. Area of a triangle. Remember that this is half AB sine C. This formula is given to you in the exams. Remember the area of triangle questions are always phrased or always put together with shortest distance questions. So how do we tabulate shortest distance from a point to a line? We always talk about the perpendicular distance. And we always use this formula, half AB sine C equals to half length times perpendicular distance. How do we spot shortest distance question is always usually not all the time. Part A will be like perpendicular distance. Part A will be area of a triangle. Then the part below will be shortest distance. Then you know you can actually use both pieces of information. Sine rule, cosine rule. So remember that for sine rule, the formula is given to you as well in the exams. Now there are two scenarios where you can use sine rule when you're given two angles one side or two sides one angle. For cosine rule, 3 marks. Okay, why I say 3 marks? Because 99.9% of the time for cosine rule questions, they're always 3 marks. So if you look at your question and then you realize that I haven't used cosine rule yet, and the upcoming question is 3 marks. Don't say I say confirm. Okay, so later I get messages from parents saying that I promise you it's cosine rule. No, I never say that. Okay, I say it's most of the time. Okay, cosine rule is when you have 3 sides equal, 3 sides given to you, you can find the angle, or you're given 2 sides, one angle, search out for the last side. Direction of the north line, this is important. Now, convention, we always assume the north to be pointing towards the top of the paper, but sometimes your north can be pointing somewhere else. Please follow, don't be stubborn. If you see that the north is pointing somewhere else, please follow all your norths and follow the convention. For me personally, if I have these kind of questions, I would tilt the paper such that my north is facing upwards so that I don't get confused. Okay. And we're done. 3 more chapters? Oh, I have time. Okay, don't need to rush. Mensuration. Okay, let's read the chat first. Wait, wow, so much. Do we have to use an example by converse over this angle parallel? No, don't need. How do I know what it is? No, I don't understand the question. I don't think so. Okay, for proving congruency similarity, how do you show common angle or common side? You just need to write. As long as it's very obvious in the question that it's a common side, then it's a common side. So I give you an example. Okay, for Valerie, if you're still here. For example, look at this triangle and look at the blue one. This is common. Okay. For regular polygons, when you say that they are similar, the triangles inside similar as well. No. You can think. Is the angle of elevation same as the angle of depression? No. The smaller of angle of elevation means the larger the length of one side of the triangle. It depends. This one depends. Yeah. Okay. Let me move on. Mensuration. Okay, so I'm done with 3 more chapters. I will do mensuration, coordinate geom, and by popularity, probability. I will skip the vectors topic and I will skip the cumulative frequency topic. Okay. Oh, wait. Is the angle of elevation the same as? Oh, yeah, there you go. Sorry, I made a mistake. Are the triangles in a polygon always equilateral? No. To Ellie, right? No, that's not true. Very simple way to prove is, imagine you draw a 5-sided triangle, 5-sided polygon. Okay, sure. I just draw 6. Sorry. Okay. Then after that, right, you find what is the interior angle. Oh my God. Yeah, this angle here is not 60. So your triangles are not equilateral. Okay. The only case where there's an equilateral triangle in a polygon is for six-sided. Yeah, that one is confirmed equilateral. The rest are not. Okay. Mensuration. So let's go. So for the planar figures, please go and memorize how to find all the different shapes. So I have a list here. Trapezium, sum of parallel lines multiplied by half multiplied by height. So be careful. Parallelogram and rhombus, remember that it is length and breadth. Now, recently I had a mock exam with my students and some gundus thought that this was the height. So please be careful. That's the side of the polygon. That's not the height. If you want to find the height, please use Pythagoras theorem to solve. For convex triangles, so this kind of triangles with like the triangles that's tilted on the one side, please remember that this is half times length times height. Now remember, whenever we draw the height going down towards the line, the length is here. So be careful. Now for solids, okay, all the solids it's a must to memorize all the solids. So for cylinder, total surface area is 2 pi r squared plus 2 pi r squared plus 2 pi r h. Now, assumption for all of this is that the cylinder is closed up. Okay, but if it's open, then you must minus off respectively. Volume, base area times height, pi r squared h. For a cone, okay, the total surface area is pi rl plus pi r squared. The value of L is calculated from slant height using Pythagoras theorem. Okay, so just remember that. And then the pi r squared is obviously the base. For the volume, okay, this is 1/3 base area times height. Okay, it's the same thing as tabulating a pyramid. The pyramid is just 1/3 base area times height. Personally, I just memorized the general form, which is base area times height. For a sphere, this is 4 pi r squared, and for the volume is 4/3 pi r cubed. For the hemisphere, it's just divided by 2. Now, why is the total surface area of a hemisphere 3 pi r squared? Because the curved part is 2 pi r squared. The below circle is pi r squared. Okay, that's why it's 3 pi r squared. Cone slant height is calculated using Pythagoras theorem. So just remember that. This concept here of arc length and area of sector. Now, a lot of students struggle with this. I do not understand why, because personally, I don't think this is difficult. Just remember that your calculations are always in radians. So for example, if you are doing like a computation, okay, you need to remember that every single angle that you use in the calculation must be in radians. So if you have like something is 60 degrees, please go and convert it into radians. Arc length and area of sector formula is given to you, so please memorize. And also the conversions between degrees into radians is this. Or if you want to use theta over 180 times pi, also can. And both also will work. Now, one common mistake about arc length and area of sector questions is that sometimes people will tabulate something, right? And then you never notice that one of your angles is in degrees. So you have an equation with both degrees and radians inside. Must be very careful. Please go and convert all your degrees into radians first before calculating the value. Coordinate job. Okay, this chapter I think a lot of people struggle with, but personally I don't think it'll be like it's a very difficult chapter. I think it's fine, to be honest. So let's go through this quickly. So first one, equation of a straight line. So y equals to mx plus c, right? You need to remember that the coefficient of y must be sub 1. Okay, if it's not the case, please remember to divide. So I give you an example here. 2y is equals to 4x plus 6. Divide down. Okay, so you get y is equals to 2x plus 3. Well, your m is your gradient and your c is your y-intercept. Gradients. So there are 4 types of gradient curves, gradient lines that you need to remember. Those that are sloping up is positive gradient. Those that are sloping down is negative gradient. Those that are going up vertically, they are undefined. And those that are horizontal, their gradient is 0. The equations are important as well. Remember that if it's a vertical line going down, is x equals to something. How to remember? You're cutting the x-axis. For the horizontal line, you're cutting the y-axis, so therefore it's y equals to something. Gradient formula, y2 minus y1 over x2 minus x1. Okay, that's the formula that you need. Distance formula, AB is equals to the square root of x2 minus x1 square plus y2 minus y1 square. Remember that this is Pythagoras theorem. So if let's say in exams you completely forget how to calculate the distance, remember it is Pythagoras theorem and you get the answer. Parallel lines. Parallel lines means that the gradients are equal. So for example, if a question says that L1 and L2 are related because the lines are parallel, and they give you one of the equations, they ask you to find the other equation, you can actually work it out because they are parallel. Okay, vertical and horizontal lines. Please remember that if your line is vertical, right, and you have 2 points that lie on this vertical line, all of the x coordinates are the same. And what is the x coordinate? It's actually the equation of the line. This is important. So sometimes questions will give you 2 points and they will ask you, oh, what can you tell about the line AB? How to tabulate? We'll just use this. X coordinates are the same. AB is vertical. That's how we tell. Same thing for the horizontal line. The y coordinates will be the same. Okay. Now, if the question is asking you for a point is a solution or point is lies on a curve, right? What do we always do? Substitute the point into the equation and then you solve it respectively. Last point here, x-axis and y-axis. So this is very common questions. If the question is asking you for what is the coordinate of the point that cuts the x-axis or cuts the y-axis, remember that y equals to 0 for x-axis, x equals to 0 for y-axis. Okay, how do I remember? X equals to 0 for y-axis, y equals to 0 for x-axis. Sorry. How to remember? Just look at this. Show you. So for example, for this point here, where is the x? 0. For this, where's the y? 0. This is how I remember. Okay, simple memorization technique. Okay, and this wraps up all the geometry chapters. Last one, by popular demand. So I'm going to skip vectors and the data analysis chapter. I'm just going to go straight into probability, and that will end today's revision session. Okay, so let's go into probability first. So remember that probability, right, is whenever you're asking for the probability of something, you're talking about the favorable outcome over the total number of outcomes. Give you an example. You have a bag of 10 cookies and 6 of them are Oreos. Okay, I want the probability of drawing an Oreo out. So since I have 6 Oreos out of 10 cookies, therefore it's 6 over 10. That's how to remember. Possibility diagram looks like this in a table format. So remember that, for example, if you're rolling dice and you're flipping a coin, your dice will be one column, your roll dice will be another column, then you just write out every single data value in the table. Just be very careful. For example, if you're rolling dice for both scenarios, and the question never say anything about like, oh, you need to sum or need to product, what we always do is to write both of the numbers like 1, 2 like this. Don't go and multiply together straight away. You only do that if the question says so. So just be very careful. Tree diagram with unknowns. So remember this, okay? Whenever we are dealing with a tree diagram, a few important things to take note. Number one, the branches here. Okay, these branches here. These branches must add up to 1 because that is the full probability mark. Okay. And then also you must be careful when you're going down from branch to branch. This example here is for a with replacement branch. So if you're replacing back inside the bag, the total number doesn't change. So the fractions here still stay the same. But if you're dealing with a without replacement question, then it's a different case already. Okay, because for example, if I have total of n balls and I take out 2 without replacement, means that I start off with n. My next time I draw in will be n minus 1. Okay, this is something that many people will forget. So please be very careful. So that's why you can see, right, from 5n, it becomes 4 over n minus 1. Why 4? Because from your red, right, you take out 1 red mark. So inside I'm left with 4. Why n minus 1? Because I take away 1 ball from all the n balls. Okay. And the last one, just down here, just a simple one. Okay, when you're dealing with OR, you're always adding, and we're dealing with n, it's always multiplying. And we're done. That is the whole syllabus. Okay, so I stopped. I never go through the 2 chapters because I don't have time. Sorry about that. Now, don't leave first, okay, because there is a little Kahoot quiz, and also I'll take questions until the AMath session. Okay, so wait first. Okay, so those that have questions, right, you can slowly start compiling your questions first. I will entertain them later. Let me conclude the session first. Okay, so all the content, right, as you can see just now, what I've done so far, okay, is all from my curated notes. So I have 2 books, book A and book B. So what's the difference? Book A is all the algebra chapters. Book B is all the geometry chapters plus all the geometry chapters and all the statistics chapters. Okay, so when you pay for the price of the book, okay, you get both, of course. Okay. I think someone just asked to go through standard deviation. Now, unfortunately, I don't have time. If you don't mind waiting for a while, then maybe I can touch on it. Okay. Now, what does this booklet contain? It actually contains a lot of examples. I've go and search online, or go and search for school papers with example questions, write like all the answers out, and then also give you tips on what to memorize and what content you need for the syllabus. Now, these black notes here, this is not in the curated notes hall. Okay, this is my own personal one. I will upload later. This is the last year version. I'm currently in the process of writing a new one. When that one is really closer to the O levels, I will upload again. Okay. Now, of course, if you need more help and you actually like the way that I teach so far, okay, and you enjoy like my humor and everything, my very cold humor, okay, I do offer group tuitions and I offer the crash course as well. I think some of my students are here. I think I've seen some names just now. So every week I'll have a 2-hour session. So yeah, you can join my group tuition if you're interested. I have an online class and a physical class. Later I'll show you the timings. Then for crash course, I also have in upcoming as well in June. I will show you the timings as well. So we'll talk about group tuitions first. So every week will be 2 hours. Learning materials will be provided. So few things that I will provide is number 1, you get the curated notes for free. Number 2, every chapter comes with lecture notes. So these are notes that I write on my own. Later I will show. Every week we'll have homework. So I will and search out for 10 questions for you to do from the whole syllabus. And you do submit to me. I will go through in class. Okay. If you want a trial lessons are free. You just need to message me and then we can organize one. These are all my timings. I currently don't have a Sec 3 EMath class. I don't mind opening one. So if there's a demand, I will. Okay, but for primarily now is my Sec 4 EMath classes that I have one class on Monday, 7:30 to 9:30. I have a Thursday, 4:30 to 6:30 class. The 4:30, 6:30 class, I think has 5 people there. The Monday online, there's only 1. Okay, and if you take notes, the EMath and AMath are side by side, of course, on purpose. So with a 1-hour break there, so if anyone wants to join EMath and AMath, you can go for dinner for 1 hour and you join back for my AMath. Okay, prices. So it's $40 an hour, it's $40 an hour. And also, right, if you join both A and E, you will get a 10% discount. Okay. Crash course. So crash courses, right, is where I will actually go into detail a little bit more, actually more detail than what I've already done today of all the topics. Now there'll be 3 sessions, 3 modules of 3 different, the list I'll show you in a bit. Okay, so it's 180 for one module, 450 for the whole package together. If you sign up with a friend, you get 10% off. Okay. There's limited seats available. So if possible, try to sign up as soon as possible. What am I going to do during the crash course? So I'll share with you first. First thing is I will recap all the topics with you. One module has about 6 to 7 chapters. So I will maybe go through the topics for about an hour. Then the remaining 2 hours, I will go through questions with you. And I will provide like new questions and everything. We will have some time in class to do them together. Okay. And also this crash course also comes with a free set of the notes. So if you're coming for it, you will get a copy of my curated notes as well. Okay. You can always head to our website to actually look for the sign up, and that's where you can look for them. Location, you'll be in Yishun, it's at Tzu Chi, Humanistic Youth Center. Sorry if I butchered the name. Okay, it's just a 5-minute walk from the MRT. It's a pretty accessible location, and my sessions are mostly at night. It's about 6 to 9 p.m. Later, I'll show you the timings now. Okay, so the way that I've done this year's crash course sessions is that I have split the module ups into module 1, the algebra topics for Sec 3 and Sec 4, of course. Module 2 will be for the geometry topics, and these are also the Sec 3 topics. So if you're Sec 3 and you're interested in them, you can come for module 1 and module 2. Module 3 will be the Sec 4 topics. Okay, so these are all the 5 topics that you cover in Sec 4s, plus the statistics and probability chapter. Okay, the dates and timings are there. You can sign up on our website. Okay, so this is the last one before I do the Kahoot thing. So resources that I provide for Overmark. So number 1, of course, the curated notes that you can purchase. I upload the free notes as well. I do know that the notes is still a bit little at the moment because I'm still writing them at the moment. So please be patient. It will come before O-levels. Monthly practice questions. So this is something that I compile every month. So every month at the start, I will upload a batch of questions, 5 questions per topic. So if you're interested, it's in the Telegram channel and also on the website. Answer key for all of these questions will be provided and they are fully worked out as well. Okay. Closer to the exams, I will always host a live stream session to go through some of the questions, the more challenging ones. But for those easier ones, I usually just use the answer key and just ask people to read them their own. Okay. Last thing is that I provide consultation, to be honest. So if anyone just needs any help for anything, you just need to message me. Okay, I'm readily available. Just PM me if I'm free. I don't mind doing a free 1-hour session with you. Okay, just take note of that. And now let's have some fun. Okay, so there's this Kahoot quiz. Now this is applicable for all Sec 3s and Sec 4s because the questions are all algebra basically. Okay, so if you're interested, what you will win from this is a set of the curated notes. So try your best. Free set of notes, who don't want? Okay, so I'm going to stop sharing my screen. I'm going to share with you the Zoom, the link. So give me a sec. Okay, for those that are interested in the physical class, right, later I can ask, I can answer. So give me a sec. Let me go to Kahoot. Okay. Okay, here you go. So this is, sorry, first time using Kahoot. Okay. Okay, so you can start to join. Okay, so as you join, right, let me share with you how this is going to work. Okay, my questions are going to be a bit different from the other subjects, because I'm a bit sadistic. So if you are my own student, you should have seen some of these questions before. So these are true-false questions. So there's only one correct answer, of course. And a lot of them is like you need to look at the equation and then you see whether it's correct or not. Okay, some are difficult, some are hard. I will explain some of them if I have the time. Okay, if I don't, then I'll just upload the answers. Okay, so maybe okay, I have 117 people in this call. So come on, join, including me. So 116. Oh, and then also, right, to the person that wins the curated notes, please PM me later so that I know who to send the notes to. Okay, I'm going to start soon. So the remaining people that haven't joined, please join quickly. $114. Okay, I'm short of 2 people. Come on, who are you? 3 people. Okay, I'm going to start. Okay, faster. Okay, I'm going to start at 6:25. Then I got time to rest for my AMAS session. Okay, I'm going to start. In 3, 2, 1. Okay, I'll read the question to you as well. Okay, so all the questions are true, false, and there are 10 in total. Okay. So, yeah. The following expansion is correct. True or false? Now remember, if you never played Kahoot before, Kahoot is a time-based thing. So if possible, go as fast as possible. But of course, be accurate as well. Three, two, one. Okay, let's. Oh. Okay, it's false. Okay, I'll explain to you why next time. But yeah, just be careful. Okay, the reason is because the minus sign, the plus sign. This should be minus. Okay, next. Wow, okay, that was fast. Good job. Okay, next. Okay, so I read the question now. There are 15 possible values of x, 7 which are prime in the range of 0, inclusive of x, inclusive of 15. Okay, answer is false. The reason is because the main mistake is that between 0 and 15, how many numbers are there? 16, not 15. And how many primes? There should be 6, not 7. Very good. You said fell. Okay, next one. Okay, the answer is false. Very simple counter example. If let's say this is P is 2, Q is 4, and factors of 4, but 2 times 4 is 8. 8 is not a factor of 4. Okay. Wow. By 5 points, sorry. Okay. Wow, 50-50 split. Ayo. Please, don't ever do this in exams. This is a very bad careless mistake. Okay, if you want to cancel, make sure you cancel only when every single thing contains the same term. So be careful. Hey, I should see who got zeros, yeah. Ayo. Okay. Oh, okay. 4 points. Wow. Okay, so the following computation is correct. 4x cubed is equals to 3x squared. You cancel the x squared and get x equals to 3 over 4. Okay, very good. To the 70 of you. Now for the 29, take note that you cannot anyhow cancel like this. This is wrong. Okay, the reason is because you will lose a solution of x equals to 0. Oh, wow. Okay. Next. Okay. Okay, so the reason is because when you cut a length exactly in half, the diagonal is not half. Okay, it's actually smaller than root 2. So be careful. Oh, okay. Very good. Someone is catching up. Okay, yeah. In case anyone is wondering why, this part is wrong. Okay, so a square plus b square is not a plus b whole thing square. So be careful. Very good. Hey, why like that? No, not everything is false, leh. Yeah. Okay. Reason is because you must divide by 2. Okay. Okay, the last one. Okay, no, this is not the last one. Oh, very good. Question 9. Okay, answer is false. Okay, the reason is because you cannot just anyhow square root like this. You'll get it wrong. Okay, this is just saying like a square plus b square is a plus b whole thing square. That's not true. Okay, the last one is difficult. So yeah. Okay, the last question, right? If anyone can give me the correct answer, okay, of course, if you give me the correct answer, good for you lah. But if anyone can provide to me the actual explanation, let me know. Okay, give you something special. Wow, the cow managed to get it. Good job. Okay, last one. Okay, the last one is false as well. Okay, but this one, not important that it is false. The question is why. Okay, so this one, if anyone knows the actual answer, you can look for me. Okay, then I'll give you something for it. Okay, yeah, everything is false. Okay, so good job for all those that realized it. Okay, let's see who won. Wow, wait, is this my student Devel? Okay, so the cow actually won. Very good. Okay, good job. Okay, can you PM me later? Can? Yeah, so to the person that's making the cow noises, please PM me later. Okay, then I can send you a copy of the curator next. Okay? Hey, that's good. Okay, hope everyone had fun. Okay, so last one. Okay, wait. Okay, so yeah, that's all actually for today. Okay, so I hope everyone had fun. Okay, yeah, this Kahoot is just purely for fun now. Okay, but I hope it's an educational value for it. Okay, so wait, if you want to move, please wait. Wait, let me talk finish first. Okay, the cow, please don't later. Okay, so yeah, I hope you enjoyed today. Okay, hope you learned something from me. Okay, then yeah. For those that are staying for the A-Math session, then you can just stay on in this call. We'll be starting at 7. Okay, then if possible, help me do a little review if you have the time. And then also, if anyone has any questions, you can ask. If not, then yeah, you can just chill here until the A-Math session. Okay, all the best. Thank you so much. Bye-bye. Okay, the cow, can you message me on Tele, please? Sorry if I'm calling you the cow, but yeah, please. Can you message me on Tele? Thanks.